This is page 7 of the notes. Purple and black are my colors. We just have a little bit left to continue. This is NS.4 Continued. We're continuing on. We had done divisibility rules. We had done factors, multiples. A couple more concepts I really need to talk about before we get into greatest common factor, least common multiple. First off, I want to talk about the term called prime numbers. Prime numbers. Some numbers are prime, some are composite, and some are neither. So prime numbers are going to be numbers that have exactly two factors. So they have exactly two factors. And what do I mean by having exactly two factors? If you remember when we were talking about factors, they are numbers that you multiply to get a product. So an example of prime numbers, a lot of prime numbers are smaller numbers. So the example I would like to start with is 2. 2 is prime. What numbers can you multiply to get 2? You can take 1 times 2. So it has exactly two factors. 2 is prime. BC in my notes is my shorthand for because. It has exactly two factors. So if I ask you what are the two factors that you multiply to get 2, your answer should be 1 and 2. 1 times 2 gives you 2. So what's another example of a prime number that would have exactly two factors? Well, another example would be 3. And then if I put ticks, is prime because those little ticks below basically mean copy the notes from right up above it. So 3 is prime because it has exactly two factors. So what are the factors or numbers you multiply to get 3? 1 and 3. 1 times 3. And then continuing on, I want you to think, what about 4? How do you get 4? Well, 1 times 4 and then 2 times 2. So it's not going to have exactly two factors. It would have more. So it does not fit under the prime category. But I can go with 5. 5, and I'll do the ticks again, is prime because it has exactly two factors. And what are the two factors for 5? 1 and 5. 1 times 5. So makes me come up with this comment. So put 3 stars in your notes. 1. What do you think 1 is? Is it prime? Does it have exactly two factors? What do you multiply to get 1? You take 1 times 1. Well, that's only one factor. That's the same number. So 1 is not prime. So it's not prime, BC, because it only has one factor. And what is its only factor? It's just 1. It's just a lonely number 1. It doesn't fit into the prime category. It also does not fit into the composite category. So that's our other word, is composite. Composite numbers. So if prime have exactly two factors, composite numbers are numbers that just have more than two factors. So composite numbers have more than two factors. There was one example I had given you up above that we did not write. It was not prime. Do you remember what number that was? That would be composite. It would be 4. 4 is an example of a composite number because it has more than two factors. 4 is composite because, so I put BC, because it has more than two factors. What are the factors of 4? What can you multiply to get 4? You can multiply 1 times 4 and 2 times 2, but you don't need to list 2 twice. So it actually has 3 factors, 1, 2, and 4. Another example would be 6. I'm going to put the ticks again, is composite because it has more than 2 factors. So what are the factors of 6? Well, 1 times 6 would give you 6, and I know 2 times 3 gives you 6, and those are the factors of 6. So you have prime numbers, which have exactly 2 factors. You have composite numbers, which have more than 2 factors, and 1, it's not prime, it's not composite, it does not fit into either category. It's just kind of its own unique number. It's just kind of lonely. So that is the last of our notes for NS.4 Continued, which would help us when we move into prime factoring and greatest common factor and least common multiple.